Okay, you guys, my name is Kalei. I've been assigned Group 10 for the combined spectra problem. I tried to do this with a blank sheet so you guys could follow along without knowing each group at first, but it was taking me too long. So I'm sorry. I know I like to look at it blank first and not know all of the answers so I can work along and in videos, but we have our infrared spectra here, our 13 CNMR spectra here, our 1H NMR spectra here, and then we have the tables that will help us propose what the structure is for the molecular formula that we've been given. So we've been given C10H12O. And to find the degrees of unsaturation, we have our formula right here, 2 times the number of carbon plus 2 minus the number of hydrogens divided by 2. So we have 2 times 10 plus 2 minus 12 is 10, divided by 2 is 5. So we have 5 degrees of unsaturation, or 5 pi bonds, so most likely an aromatic ring in our structure. Then we have our infrared spectra that's going to help us determine the functional groups that are present. First look here to see if we have that broad trough at 3300, which would be a alcohol group. We do not. The first signal that we have is 30,000 to 3100, which is significant of a sp2 carbon, or a double bond to a carbon bonded to a hydrogen. Then at 2900 we have our sp3 carbon, most likely an alkane. Then we look to see we don't have any signals between the 2000 to 2500 range, which would signify a triple bond. We don't have that. The next deep signal that we have is at 1700, which is awesome because that tells us we have a carbonyl. It's an easy one to recognize. At around 1640, but right here it's really like 1600. We do know that alkenes show up around 1640, 1680, the medium signal. So we can get that there. And then it is true 1500 and below is usually our fingerprint region, but we have a region right here, a medium-sized signal between 1400 and 1500, which would be significant of an aromatic ring. So just plug that into our chart down here so we can keep our grab the information from that. So we should put 5 degrees unsaturation. Our molecular formula is C10H12O. It's the molecular formula. Then we can move on to our 13 CNMR, which tells us the unique carbons that we have. And it also is important to know that we have 10 carbons, right? And we only have 1, 2, 3, 4, 5, 6 signals. So we know that there's going to be symmetry somewhere, most likely in our aromatic ring. And then real quick, this is upfield, downfield, less shielded nucleus, more shielded nucleus. We have more of our electronegative atoms on this side that are pulling it down, de-shielded our less electronegative atoms up here. So this would correspond to our carbonyl right here around 210, 220. Then we know that alkenes can have, okay, sorry, I had to pause, help my kids for a second. So we're talking about this one, which I have changed my mind about. We know, like I was saying, that this 13 CNMR spectra shows the unique carbons. And I want to erase that, but it's not coming, so we'll just hit it up. Okay, well, I want this to be red. It's not working, but this would be red because there's going to be probably 3 different signals from our aromatic ring because there's most likely not symmetry, especially if there's a carbonyl group over here. And so these will be different signals on the aromatic ring. So let's just say this is red. Then we have our CH2. It shifted downfield a little bit. We know normally that CH2s around like the 30 area just downshifted because of the presence of the carbonyl. The same with our methyl group is normally around 20, or shifted it just a little bit downfield because of the presence of the carbonyl. So there we have our 13 CNMR. So going down here, yeah, so our 30 ppm is our methyl, 45 ppm CH2, also downfield because of the carbonyl. Our aromatic ring groups, those three signals around there, and then our 210 for our carbonyl. So then we'll go up to our 1-HNMR spectrum that will help us determine a little bit more, gather a little bit more information. The HNMR is pretty cool because it helps us with the integration. That's what these numbers are. Tell us how many hydrogens correspond to this signal. So we have 5 here, 4 here, 3 here, which put all together is 12, which is what we have in our molecule or our molecular formula. So that is good. And then we go down to this table, our multiplicity of it, we can find using this, and that using the neighboring number of hydrogens plus 1 equals the number of peaks. I'm not sure why this, yeah, we want the number of peaks here. So this is most likely from our aromatic ring since there's 5 hydrogens. It's kind of hard to tell how many peaks exactly there are. Let's see what I put down. I put a triplet, but I think that there's more. It's kind of hard to see exactly how many peaks there are, but probably more than a triplet. So once again, significant of the hydrogens on the aromatic ring. And then going here, I would say that's for our sp2 carbons with 2 hydrogens. So here's our phenyl group, right? And then in between we'd have 2 sp2 carbons, or our 2 carbons with 2 hydrogens on them each. So each neighboring carbon would have 3 peaks. And so I think it'd be a sextet. That's what I have written down here for our CH2. And then lastly, our methyl group, because it's right next to the carbonyl, which has no hydrogens on it. And so it would just be 0 plus 1. So that means there's 1 peak for that. So filled in our table here. So this is the proposed structure that I have, phenyl group. So we have, let's count our carbons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our hydrogens, 3 here, 2, 5, 7, 8, 9, 10, 11, 12. Where am I off? 3 here. Oh yeah, I counted 1 here, but there's actually not 1 there. It's just 1 right here because there's already 4 bonds right there. So it'd be right here. So the name of this structure, what structure that I think it is, would be, if I can get my thing to work, it would be the 4-phenyl butyl it's a ketone, butanone. And this would be 2. So that's what I think it is. There's that. That's how you'd use the combined spectras to figure out what your molecule actually is. Thanks. Just wanted to add this E right here that I forgot. That's it.